3D. Sometimes we have two terms to talk about 3D reconstruction, 3D 重建. One we call shift from shading, shift from picture, shift from focus, or shift from motion. So shift, axis meaning like this one. So shift is in 3D. Or sometimes we call structure from. So when you see something, talk about is shape or structure, this one. Shape or structure means 3D reconstruction. And the method from something, this is method. So shift from shading 就是从阴影 shift from picture. Focus 是 this one. 我上都有举例了哈，这些都可以做3D，用画成这种深浅 shift from shading 阴影，从阴影可以做3D 重建。shift from picture 纹路，shift from focus 聚焦 focus， 自动对焦，不同对焦 focus on background, focus on foreground, and we can do 3D reconstruction. And shift from motion 就是移动就可以做3D 这样子。Or structure from something. 那这个你们剩下我就不讲了，这你们自己在看。When you see a 3D movie in 3D, you need to wear something red and green goggle. 这个就是看这种视差，3D 层可以看到视差，就是根据你的眼睛视差。再代替一下。So we start to talk about stereo. So what's the stereo? Stereo, we try to simulate our eyes. Okay, so this is the left image, right image. And how can we find the disparity, the depth between based on the left and the right image, the depth, 这个深度长，那我们怎么找到这个深度长 based on left and right image? Okay. So if we put both image to be top and down, 我们把左右放成 top down. Okay. So you'll find the objects closer to you, the objects close to you. So the corresponding point, this point, actually that point, based on left, 这 reference image based on left and right. So based on left, 从左边去看嘛 left， 然后东西会右边。So based on left, and how do you find a corresponding point here? So you search right, left hand side. So based on left, you project to here. You search from your left hand side. And so the distance between two points we call disparity. 这视差。上面那张的点放在这里，那这两张的位置，这叫视差。那这就是 so when the object closer to you, this disparity will be bigger. When the object is far away from you, 那点刚好这里是这里，那这是 disparity was smaller. So based on the disparity, we can reconstruct to 3D. 左右这样子。The other thing is that you will find at any point you see from left hand side, you project overlap to an overlap together. Okay, you'll find your corresponding point will be in your left hand side. You'll search corresponding search this way. 就是你就上面左边的任何点投影到这边的话，你的相对应点一定是在你左边，不会在右边，你只是换一个方向。因为你左边这样看，一个右边这样看，对，左边看到点，投影到右边，一定是往左边去寻找，这样子是摄取。那我们会有几个问题，这里会有几个问题的产生。我慢慢，所以 this is some example。这是我那时候写的程式，其实拿人家500万美元在做这个。再带一个小题。 all the 3D algorithms based on the triangulation， 都是用相似三角形量测的方式。All the 3D things, the theory is really easy. Theory is very easy, but in reality, it's not easy because a lot of noise. So based on the triangulation, so how can we find the depth z? Z is the depth, the 深度 z. Now how can we get this equation? 我这有3个 3 methods, okay? But forget 1 and 3rd. You just focus on the second method. So how can we get this one? Okay. So this is here. Okay. So suppose there's 3D points here, on any point 3D point, and this camera center, this one camera center 1, camera center 2. Camera center 1 is left, camera center 2 is right. And between 2 camera center, the distance between 2 camera center we call baseline. So baseline is this one. You have left camera, right camera, and the distance here is called baseline. Okay. And this is the image. Suppose image here, virtual image here, and virtual image here. Okay. If both cameras are the same and they have the same focal length, so if usually we get the 2 cameras are the same camera, 就相同规格的 camera， 那这是 focal length 会一样 ，the same focal length, and this is the image. So how can we calculate? How can we find a z? Problem is, how can we find a z? Okay. So this will be this way. Or we don't do this. We can do exact. Any points. So any points. So this is coming out. So this coming out. So this camera center 1, camera center 2, and your base. Okay. So your optical axis. Optical axis. So you have image. So this one, suppose this image here. So the image 1. So this focal length. Image 2. This also focal length. So you have a triangle. And you try to find a z. You don't know the z. So the question is, what's z? So z is from the baseline to here. This is z. And this is f. So our similarity measure is this one. This triangle compared with the bigger one. So our measurement will be this triangle compared with the This is you don't know Z, but you only know F. This F focal length 就是两个三角形的比，两个三角形的比。So your comparison is baseline, right? This baseline. So your method will be baseline. The high compare with the baseline. Equal to this high. So this high is Z minus F. Dash三角形，大三是 Z compare with B baseline, and equal to the small one. So it's Z minus F is this high, and compare with this one. But what is this one? And this one is B minus this, because this is x1, and this is x2. It's x1, x2. It's x1, x2. S1, x2. 就这样，这样是 x1 减 x2。如果它是讲向量，这样基本是 x1，你先写 x1 加 x2， 我待会再解释给你。所以 z high compares baseline equal to the small high， so z minus f 就跟 f b， 那 b 就是 b minus x1 加 x2， 就这样。You don't know z， 你要求 z。Stereo is you doesn't know z. You want to find depth z. And baseline is you design. The two camera you design two camera to put the distance between two camera. So sometimes it's just either 3 centimeter or 5 centimeter. 通常不会大于3，我的经验没有超过30，30实际上已经很大了。我那时候做100公尺的那个圆，我的 baseline 才15公分而已，还蛮准的。他要杀头，他们那个杀那种高热量镭射嘛，就要去杀头，有人就死倒下去，就一股烟出来，烧就是镭射传过去，冒烟就死掉一个，所以要很准。那这 B 减掉这 x1 x2 一起。这距离是 x1， 这是 x1。Here they write u1， 这 optical axis 这个this image， 这是它距离 x1， 那这距离是 x2 这里。你好，所以这个距离 this distance is b minus x1 plus x2. The distance x1 plus x2. 我再重写。Next page.啊，这是不是向量，是真的距离啊。 here. Here. Because in this case, x, suppose this is 0, 0 from the image 0, 0, so this is positive, 这正的 x1. And you will find this is 0, 0, and this is negative, 这是负的，这是负的。所以基本上这个，如果以向量来讲呢，是 x1 减掉 x2 这样子。如果以向量来讲是这样子，那这是负的值 ，x1 是大于0，这个是小于0。可不管，以向量来讲是两个向量的是这样子。基本上，先不管这个。Okay, so that's the next page. 我把写相反，抱歉。把写相反。那这个 called disparity， 两点的距离 ，the distance between this distance between 2 points. This one we call disparity. Disparity 是那个视差，是它的距离。It's called disparity. The distance between 2 points. The distance between 2 points. We call disparity. So we try to find z, and we're given b. B is you design, you study B design. F is you do calibration. Intrinsic parameters F. You do the calibration F. So you know z, you know F, and you need to measure this one. So for the stereo is you try to find the disparity. If you can find the disparity, you will know the z. It doesn't know z. So if you calibrate, if you measure, you find this d, this disparity d, you will find z. 这样子。Stereo 就是两颗摄影机，就是回到这个地方。So based on the algorithm. For each point, if you find a distance between this one, we call disparity d. You find d, and you can, based on baseline, based on focal length, you can understand, you can find the z, the distance from the object to you. So that is disparity d. Disparity. 只要找到find the corresponding, 你只要找到 corresponding point. After you find the corresponding point, you get the z. This the theory for the stereo. So finally, the result is this one. 你把这个整理一下就变成这个。So this calibration, based on calibration result, focal length, and given B, you design, and you measure D, and you get a Z. So anytime you measure D, you get a Z. So entire image. So the problem for the stereo is that each pixel, you need to find the corresponding point. So this is called corresponding point. Each point, you will find corresponding point. So if the image resolution is 640 by 480, 1000. 解析度比较小。If image resolution is this one, so you need to find so many points for the corresponding points. So it takes time. But right now, probably your image resolution 2K. 2K times, I don't know, 1400多. So you take a lot of time. For a stereo, we want to do the real time. So the problem for the stereo calibration for 3D reconstruction, the theory is easy. But in reality, it's not easy because if you want to do the real time, if you calculate so many corresponding points, take time. 1秒钟30个 frame，1秒钟你有30个 frame， 所以你怎么去算你的 ？Why we need 5G？ 你的 streaming 那个 video streaming。 有 video streaming， 你要怎么算？假设你2K 好了，我用怎么说啊？这个2K 乘上，这是1.4K， 这是你的影像 resolution for image， 那你要1秒钟30个 frame， 1秒钟30个。 那你要你的那个，然后一个 pixel 是0到25嘛，就是8 bit， 所以你要乘上8 bit， 对，8 bit， 不晓得我有点忘记，是30 frame， 对，这是一个 frame， 然后8 bit， 是这样子。然后这黑白的。 这样不知道多少，这里有2个 K 就6个0，对，6个0 7个0，将近8个0，所以这里会乘上10个80， 1秒钟呢传这么多 bit， 所以会传不动。但是那个 5G can solve this problems for stereo or depth。那个 video stream 传输速度，这个这样说，这个大概这样说，就速度乘上30 frame per second， 啊 bit rate， 手机要接受，4的80，我是随便算，8个是多少？那个3个6、7、8，各是10。 1秒钟传1亿个，对吧？不是要传1亿个，1秒钟传1亿个 bit， 这样收得到。那 the other one should be careful is this one, the unit. Z is usually centimeter, millimeter. Z. And baseline is centimeter. Focal length is millimeter or centimeter. But this one, your display pixel. Pixel is sometimes micrometer， 所以这个转换是要小心一些，最少是单位转换，要小心一些。这可以做得很准，因为我做过100公尺，可以瞄得很准，只要设计好的，可以瞄得很准。好。So this equation. So what's the problem right now? This equation. So the problem we back to here. Okay. So what's the problem we need to solve? So the problem is to try to find a corresponding point. So right now we face a problem for stereo. This one. So for stereo, we try to find corresponding point. This page 35, 35页这边啊，就是那我也跳掉。Find 2 points. How do you find a corresponding point? So there's matching problems. So this is one image. Right? this second image. Left, right. So any points here, and you try this correspond to it. So how can you find the corresponding point here? This corresponding point. So how can you find this? So this will be distance d, disparity d. So how can you find this point? That's the problems. So this become matching problems. Matching. So matching problem. 找到相对应的 matching. So matching problems. Now matching problems is a similarity measure. So it's back to detection, tracking, recognition, all the matching problems. Okay. So matching problem is the first one. Into a search range. So this first of all, can you find based on 1 pixel, because only 1 pixel, can you find corresponding pixel? Can you find a corresponding pixel? 我那时候在 CMU 的时候，跟老师 meeting 都很紧张，因为市场好，目前教育制度比较好的，整个教育制度比较好是医学系。那医学系为什么台湾整个教育制度最好还是医学系那边？为什么医学系教育制度比较好？师徒制，你看到最后实习是师徒制。那美国也是哦，你不要小看，我们台湾都讲说，知道台湾，因为我在美国待11年，然后带过3个学校，算都不错的学校，还有顶尖学校。我发现还是师徒制很重要。德国是完全师徒制。那你看美国，它市场最后也是师徒制，就是你跟什么，最后要跟老板的时候都讲老板。那所谓师徒制，是不是就像我跟我老板面前的话，每个人教育出来的就是不同老板教育出来的会不一样，没有说好或坏，就是可能因为我老板是美国国家院士，所以他很严格，所以跟他面前，他常会丢问题给我们，然后叫我们问完以后，然后叫我们写程式，然后隔天就要结果，所以遇到你，去上，所以他上厕所的时候，我们最怕跑出来上厕所看到你，就问你，昨天meeting的结果 ，show me something。所以博士读5年，被骂3年，紧张。那他就问我，那时候也是问我，说 ，Can you find a corresponding point based on 1 pixel？ 我回去就想了1个晚上，没办法睡觉。因为我知道里面不是我meeting，我1个礼拜meeting1次，因为他遇到我一定会问这个问题。还好他没有问我问题，但是没有问我问题我也紧张了。你问我问题我紧张1天，我没有问我问题我紧张7天。等到下次meeting的时候，他问我，我们老板聪明，老板号称是全日本智商第2高的，我把他多少？所谓智商高的，我们那边很多天才，我才发现原来智商高的是，我不知道真的有假的。他说他一年前的 schedule， 他记得起来。1年前的 schedule， 他整天 schedule 他记得起来。我不知道真的有假，我一直很不相信，我不敢去问他，但他是很聪明，因为他发明到东西。那他就问我说，一个 pixel 怎么去 ？How can you find corresponding point based on 1 pixel？ 那1个礼拜他问我，我说我真的不知道，我找配合怎么不知道？那时候是2年级比较敢，1年级不敢，2年级就国2的时候我敢问他说，那老板你的答案是什么？以前不敢问的。我老板说，我也不知道啊，不知道才问你啊。原来他也不知道，原来他什么都知道。OK， 所以没解，他只是提出 Q&A 嘛，提出问题。好，所以 1 point cannot find corresponding point， 所以 you need to a page。So this page， 什么 page？The same thing that so we do 3 by 3 page. Why not 5 by 5? Because 5 by 5我说到，你 streaming 就会 你现在是一个 pixel 呢，如果再加上那个search range 的话，要更多，还有 search range， 还有那个 window size， 是 big one。So it's 3 pages. So first of all is the page size, 3 by 3 or 5 by 5. More than 5 by 5 is just well slow. And the second one is your search range. So if you try to find a corresponding point, 这里会有There's like you cannot find corresponding point from left to right. 这就不行，这不是什么事情都可以解决。就写这样，就再重新整理。Back to here. So find us for the simulating measure 相似度的话 ，detection tracking the condition. So first one is your page size. Page size 要多大 ？Page size. The second page size the same as filter size or kernel size. And the search range. 你要找的 search range 要多大？就这两个。You need to consider this one, both. So try to find corresponding point to things. Try to find corresponding point. One is the search range. So your search range. 你要找到对应的点，所以你要 search range. 2D search range. 2D search range. And window size. 这两个。那第三个就是那个叫 metric 嘛 ，MBTI 就你的衡量机制是什么？ metric 就是衡量机制。matrix 就你的用 sum square difference 那个 loss function 那个东西 ，loss function 是什么？基本上就是这个 simulating measure 就是 page size search range。好。 Try to find corresponding points. So, for the matrix search range here. 在这里有写 find corresponding point， 所以 you need to consider search range, you need to consider the metric window size, and the method. Method is a metric， 就是3点，在35页帮你写。So for one point, it is impossible. But for the edge, some paper try to find corresponding point based on the edge. They do edge detection. Based on edge. Why we did do edge detection? Because many objects has no edge. So originally this entire image. But after do edge detection, many value are 0. 很多值都0，所以那就不理它。但是会产生洞，又 create a hole in the disparity. So when you do a disparity, you will find a lot of holes. So you need to fill the holes. We'll talk about that one later. Okay, 那是 feature. Feature 就是 page. Feature 就是个 page. Features mean the page. This is a page. what's the method? Method is, we already talked about method. Method is some, as usually for stereo, because a lot of computation, so the metric usually use SAT。不用太难的方法，因为它运算量太大了，所以通常只用 SAT 来做。我们有 sub-square difference， 就是 sum absolute difference， 就是 summation 就两个相减，比较简单，相减，不取平方，平方太麻烦，所以相减 S， 就每个 window 就3×3，9个 pixel， 然后每个 pixel 相减，对应相减，这值越小越好。越小越好，把它写详细。你看写详细是你希望你的 error 最小，那这个 error 就是你要 minimize 这个 error， 你希望找到最小值，就 summation x 轴 summation y 轴，那就是负1到1 ，y 轴负1到1，这是 page 1，到 page 2。Page 1是减掉 Page 2 X 负1到9宫格，3×3，每个 pixel 拿去找search range 找最小值 range， 所以你的 metric 就是这个 SAT， 运算量太大。几乎那个 stereo 都用 SAT 来做，其他方式太麻烦。那 deadening difference， deadening they use that phased RCN， 他直接去找 region 啊，不一样。好，那我们再讲。search range。So your method is use this one. Method this one use SAT 就好了，不用太准。OK， 那 your method use page， but some people use edge， 只用 so-called edge 的东西来做，这两个都可以。这个目前没有想不到。How about the search range? Okay, so back to the original one. So 2 camera, stereo 2 camera. And how can you find the corresponding point here, pitch? First of all, you need a search range. So search range is 2D. This is 2D search range. Try to find corresponding point. So can I reduce 2D to be 1D? 2D become 1D. Can we do that? Yes. So if you search from, we reduce 2D to 1D, they call epipolar. They call epipolar. That's meaning this line. Can we find the corresponding line in the other image? If we can find corresponding line to this one, you just search along this line, you find the match point. So you will reduce the search range, the calculation from 2D to 1D. And OpenCV, they give you all the source code for this one. And this line we call epipolar line. Epipolar. So I'll teach you what's the epipolar line. So from reduce the 2D search become 1D search. So 要找 epipolar line 这样子。这样的问题就是刚刚讲配取3×3就好了，然后用 SAD， 然后最后剩下的 search range， 那我们找 from reduce search range from 2D to 1D。So how can we find an epipolar line？ 那 OpenCV provide all the source code for you for this one. I think that remember I showed you this one before. So this is so that if both two images are parallel， 这两个线就放在平行的话，那就可以。那 if you can find corresponding point, this is virtual image, and you can do it this way. Do interpolation， 两个线距我都放得很平行，我就可以中间这是假的，我只要 left right， 然后可以做这个。好，那可是当我有这个的时候，you take one image， 在某个角度拍一张影像，再走到这边，在另外一个角度拍一张影像。那你怎么让两张影像产生关系？就这个。那你 if you can find corresponding epipolar line， 这就 epipolar。这些线叫 epipolar line。我教你，然后 OpenCV 都帮你程式写好了。你要扣就会帮你把这个 epipolar， 每一条线 each epipolar line they will find corresponding epipolar line. That's meaning the point here, the corresponding point will show along the epipolar line. 那意思是说，你就可以在这中间这些点，用那个内插的方式，去把虚拟的点找出来。那这样就会产生这样子，这就是假的。This image is not real. You have only left, you have only right, but you can create this one. So this is an application for stereo. 那这样就不用很多颗摄影机了，我只要这样拍一张，在这里再拍一张，都是 video， 它中间就是假的。那我说放10颗摄影机，你现在看那个，这是我老板发明的，你有看那个什么棒球，是它有那个这个角度看不到，它重播的时候拍另外一个角度看，转的，所以就可以看到这个状况。那个卖多少钱你知道吗？1.2亿，20颗摄影机加上软体，1.2亿，在棒球场，新庄棒球场，你我去看。我看完说，这是我老板发明的，2002年就做好了，但是美国卖更贵，美国转播一场球赛要$100万给CU。100万美元一场，所以美国那些大联盟决定不用，太贵了，一场要100万，所以美国那个转播费很贵。 他们只转播一场就不转播，所以那个只卖那个 football 一场，就这个啊。所以 this is a epipolar。讲时间啊，讲一次。So what's the epipole? It's meaning 3D points. How can we reduce 2D to 1D? This point. Okay. So point project this image, virtual image, in this camera center, and this the other camera center. Okay, so point project here, and this image will be P left, 2D point P left. This point project to here is P right. 我要跟你讲，因为我要做这个，所以我们现在的中正纪念，不是中正纪念，我们的中正堂要有20颗圣经，游泳池也要有，所以我们现在建制，校长支持，我们要做这个，就是不同 view 的东西这样子。好，我们就是我们开始在建制了，以后中正纪念堂可以租给人家那个球赛或者演唱会，那演唱会就可以转播，不同视角可以做转播。那为什么要做这个？因为以后你手机可以自己看，不是电视转播，因为5G 来了。然后我们跟台湾，因为我现在在那个叫什么运算中心那边，所以运算学院就你们有些人有申请，我们要做这个。台湾固网已经要在我们的中正堂那边架5G，就中正堂那边出那个片就看不到。所以你就可以在自己手机上看那个你想看的视角，这样子。好，那一次可能10颗、20颗摄影机全部把 video stream 全部传到你手机上，你自己选视角自己看。好 ，OK， 回到这里，只要你有兴趣的话，我们就是根据这些原理来做。所以 this P left, this P right, 2D points. And actually, this is a camera center. So camera center will project to the other camera center, and this point called epipole. Epipolars. Data epipolars. And this camera project to the other camera center. It is called epipolar. Left, right. 这个 open